Hello everyone, and welcome back to our linked list lecture. Now, we're going to start with programming a simple linked list. For that, by the way, I'm using the idle shell, which is the editor that comes with Python. You can use this, PyCharm, or any other editor that you like. Before we start programming, let's remember together what a linked list is. It is a number of nodes that are linked together. So if we remove the link right now, it is a number of nodes. So if I create one class for a node, I can create many nodes from it, and then I can link them together to make my linked list. So the simplest thing that we can start with is actually creating the class for the node. Now, what we are working with right now is something called the singly linked list. A singly linked list uses a node that has one value, one data, and one pointer in each node. There is something else called the doubly linked list, which uses one data and two pointers. So far, I think you have read this in your theoretical lecture, and if you haven't, I encourage you to go back and review it. What we're working with today is the singly linked list, so each node is going to be made of only two parts, one data and one pointer. So I'm going to start creating this class, which is for the node, class node. First letter is capital because it's a class, colon, and we start. What I want to do is initialize it. So I'm going to create a method. We're going to call it dunder init, which Python already recognizes. We have talked about it before. It is used for initialization. And I'm going to give it self. You can use your own information. And when I'm creating a node, I just said that a node has two parts. In this singly linked list, a node only has two parts, one value and one pointer. So the value is going to be sent by the user when they are initializing the object of this node. So user is going to send data in here, and we are going to create right now, we are going to create a variable for this class, self dot, it's called data, that is going to house or hold the data of our class, of our object later, and it equals data, which means this variable in here, which is related to the class or object that is going to use it, equals this data, which is this one, which the user sent. So what we're basically saying is the user is going to send data and we're going to give it to our class's variable. So every node has two parts. One of them is data. We just did it. The second part is the pointer. Self dot. Normally, the pointer is called next because it's next in lines, pointing towards the next node. It's going to equal none. Now, none is the keyword that Python uses to say that it points toward nothing. Java and C++ use the word null. We're not going to use it in here. So why is it not connected to anything? Why is the user not sending the pointer for the next? Because sometimes, or actually all the times, and the majority of the time, what we're going to do is create a node alone. So it's going to be separate. And then we're going to be able to find a location for it to insert it. So it's going to be easy to insert it at the beginning by just saying this node, this next, point towards the head. And it means I just linked it at the beginning because the head always points toward the beginning. Or I can say this next points toward this node or that node. And that is going to create a link and it's going to make my linked list. So after I do this, after I create this initialization method, what I want to do is create another class. And you can see so far that's really simple. I made the node. Now I want to create the linked list that is going to use this node and other nodes to do something. So what I want to do is another class, and it's going to be called linked list, again starting with the capital because it's a class. And I'm going to do define dunder init, so another initialization function. Now, this initialization function, look, regarding a linked list, it is a collection of nodes, okay? And I created them here. So why the linked list? Because every single linked list has a pointer called head, which always points at the beginning or at the start of a linked list. And if you look at this class in here, there is no pointer called head. We only have next. So I'm actually going to create it in here. And what I'm going to say is, in this initialization, don't send anything. And what you want to do is self.head. I'm creating it right now, and it equals, again, none. Don't point towards anything. Why? Because when we create an object from this class for the first time, there is no linked list. So head is pointing towards nothing. We are going to create it. There's no linked list. And then we're going to add nodes to it. And from that point, we're going to start to create our linked list. But at the initialization, when this starts, there is in reality no linked list. You just created it. You didn't add any nodes, so it's still empty. So head is pointing towards nothing, towards none. I'm going to add a second function in here to print the information or the data, this data of my nodes. And I'm going to use a function that's going to make it much easier and more secure to use it. As we have learned so far, if you want to protect your data, you should put the variables, attributes, or data inside of the class and protect it with methods or operations that we also have inside of the class. So I'm going to do a very simple printing function or method, sorry. I'm going to call it define. Let's call it print list. Again, first letter is small. That's because this is a method, not a class. It doesn't require anything because I just want to print the information in it, so I don't need to send anything. Just call it, it's going to print the information. What I'm going to do in here is traverse my linked list from beginning to end and print every single item or data that I have in my nodes. Now, if you remember from the past lectures, it is kind of hard or actually new to traverse linked lists. What we need to do is start at the head, which is always pointing towards the first location, the first node, and jump to the next, until the next value is none, is nothing. It says you have jumped throughout the entire linked list. And I'm going to do this now. I'm going to say, this is a new pointer called current, because it means my current location, and it equals self.head. And as we said earlier, the head always points towards the first location. So what we did, we said, we have a pointer and it's looking at the first location in our linked list. Now, in here, I have a while loop that's going to jump throughout the nodes, but it's kind of weird or different. I'm saying while current, and that's it. There is no equals true or false or equals 1 or 5, is or is not. There's nothing, just while current. That means while current is something. While current is not none. And this is exactly what it means. And that is why it's beautiful to use Python with linked lists, because this none means nothing. And I'm saying while current is something, the opposite of nothing. So when my current, this pointer, jumps from the first node to the second to the fourth, fifth, when it jumps to the last one and it's pointing towards nothing, it's going to jump to nothing and comes to this condition and say, am I something? And it's going to say, no, you're not. You're pointing toward nothing, and it's going to stop. What I'm going to do in here is very simple. What I want to do is print. And I'm going to do a simple print where I say, my current is pointing toward a node. A node has two parts, data and next. Which one do I want to print? Of course, I want to print the data, the current.data. I'm going to use an attribute of print. This print has an attribute called end equals space. I'm putting a space in here and I'm closing. If you don't use this, by default, end equals end line or a new line in C++. So if you've been using a print inside of a loop, you realize that it's going to print on the first, then second line, third line, fourth line. It's going to print and go one line down. If we use end equals space, it's going to print 1, 2, 3, and 4, not 1, 2, 3, and 4. Okay, so by default, end equals end line or new line. We changed it to space. If I run the program right now, it's going to go into an infinite loop because current is still looking at the same location. I want to make it jump to the next part. What I'm going to do is current equals current dot next. So what I did here is say start at the first location, start at the head. Am I something? Did I reach the end? No, you didn't. You are something. Okay, then print the data of it and put space after it. Then jump to where I'm looking at next. And it's going to jump from one to the second to the next. That's it. It's very, very simple and it's very actually beautiful. It's much simpler than using any other programming language. It's fairly similar right now, but believe me, as you go further and further, it's going to be much simpler. What I want to do right now is make the main. So far, I don't have any main program. I have two classes, but I don't have any objects from them. The main program is going to be simple. I'm going to create an L, which is an object from the class linked list. So this is an object from this class up here. And since it's an object of it, so the initialization, as you saw, there is nothing in here. When I created the object, this was executed. So right now, L has a head that equals none. It's pointing towards nothing. And if I write L.print_list, it's going to print, although the list right now is empty. We can actually, later on, we're going to add an if statement in here that checks if the list is empty. For simplicity's sake, we are not doing this right now. What I want to do is say L.head, which is right now none. There is no nodes. I haven't created any nodes, equals node. I just executed or called this class to make an object from it. I'm going to give it the number 2, an integer of 2. Enter. Then I'm going to say L.head. If I say L.head equals node and give it something else, it's going to change it. I don't want to change it. I want to link with it another node, linked list. So I'm going to say, oh, so head has the number 2. The next of the head right now is none. Dot next equals another node. And I'm going to put character X in here. Then I'm going to say the L, my linked list object, dot head, look, dot next. So my head has the value of 2. The node that is right after where the head is pointing has the value of X. The one that is after where the value of the head is pointing, do you see this? Like head.next. You can do this for however long that you want, equals, and I'm going to put node, woohoo, because you're going to be super happy that we're finishing in here. Let's make it in all capital because you're happy. And what I'm going to do is enter. So what happened in here, we said the head's value is 2, right after it is X, right after that is woohoo. But I don't know if this actually was executed, so what I want to do is call on the print list. I'm going to say L.print_list, which is this function in here. It doesn't require anything, so I'm going to open and close parentheses and run. It's going to say, do you want to save it? Yes, please. And when you look here, 2, as we say, X, and woohoo. And that means that what happened in here is we created a node and we said, this is your information. Right next to you is X. Right next to that is woohoo. This is a very, very simple program. Later on, we're going to change that. We're going to create the nodes and actually connect them one to the other. We're going to know to know how to add and delete, how to insert and remove. But for this lecture, this is more than enough. I would like to thank you so much for listening from me babble for so long. I hope that you get some benefit out of this lecture, and I hope to see you on the next one. See you.